Hello everyone, welcome to today's session. Just give me one moment, I'll check if I'm online. Alright, so in today's class, what we're going to do is we're going to see in one shot, we're going to complete, we'll learn about what is a dimension and what are the application of dimension analysis. All we are going to do is about dimension analysis. It's a class we've already done, but because of some technical issue, the video is actually hidden. So I'm just going to repeat the same class. All right. So if you have any doubts in dimensions, you can take this opportunity to actually ask all your doubts as well. All right. Now, before we begin, my name is Mohana. I'm a physics educator here at Unacademy, and I'll be taking class 11 and 12 ISC physics, ISC board physics. Now, this is my Telegram channel link. Before any class goes live, I will share the details in this Telegram channel, so you can follow me here. As well as this is the common ICSE and ISC board Telegram channel link. Alright, so you can follow this channel as well. Now, just like how we have the classes on the YT platform, right? Likewise, we also have classes on the Unacademy platform, and those classes are absolutely free. So these classes, we call it as special classes, and you can take any of your favorite educators' classes for free, and you can engage with educators via poll feature. And if you have any doubts, right, you can get those doubts cleared as well, because those classes are also live classes. Now, if you actually go down to the description box, the link will be given to class 11. If you go there, I'll shortly update within a day or two the upcoming special classes for the month of August. Alright, now the advantages, in case if you're interested in the plus subscription, there are some advantages. One is you can learn from the comfort of your home, as well as whenever you take a plus subscription with Unacademy, what you're getting is 4 subjects, right? So you will have physics, chemistry, math and biology, and you will have unlimited access to all these 4 courses. Now you'll be learning from the top educators, as well as every 4th session is a doubt clearing session, meaning first 3 classes, whatever concept you're learning, 4th class, it will be more like a revision or a doubt class. All right. So every 4th session in your plus class is a doubt clearing session, and in your plus course we will 100% cover your entire syllabus. There are many practice tests available. Whatever the study material or the can be downloaded in PDF format from the website itself, as well as the there are many live test series. Every other week you have live test series followed by an analysis session with the educator. The upcoming courses, I'll tell you the details shortly. Before that, with Unacademy, the longer duration you take a course, the price per course, price actually per month or goes down, right? So here, right now we are back with the 41% off offer, where if you're taking a 6 months course, right, you will get 1 month extended for free. So you get basically get the course for 7 months, and you have to pay only 9,200 rupees. So you're saving 29%. Okay. But if you take the same for 12 months, you get 3 months extension. That is around 15 months, and you only have to pay 15,870 rupees, right? Per month, you will pay 1,000 and odd rupees for 4 subjects, physics, chemistry, math and biology. That's the amount you're paying for all 4 subjects for 1 year. If you're taking, that is for 15 months, you have to pay only 15,870 rupees, and you're saving 8,301 rupee. Now, for 24 months, in case if you're in class 12 or in case, class 11, or in case if you're in class 10, you can go for this 2 months, 2-year subscription plus 6 months, where you have to pay only 26,450 rupees, and you can save 18,113 rupees. Okay, you can save up to 41%. Now, to avail this particular offer, you can use my code MTIS10. So if you haven't taken the plus subscription, do take it, and this offer is again back extended up till 31st July. Now, the upcoming course that we're going to have is the Brahmastra course. This is again an all subject batch, meaning you will have 4 subjects: math, physics, chemistry and biology. For every Tuesday, Thursday, Friday, you will have your physics classes between 5:15 to 6:15 p.m. I'll be taking. Now, before the physics class, 4 to 5 p.m., you will have chemistry classes with Manisha ma'am, and on Monday, Wednesday and Friday, between 6:30 to 7:30 p.m., you will have math classes with Rahul sir, followed by 7:45 to 8:45 biology classes with Lakshay sir, right? So in a month, at least minimum of 10 to 12 classes or more than that will be there for each subject. So overall, in a month, a minimum of 50 classes will be there for all 4. All 4 classes put together. Minimum of at least 50 classes will be there. Each class having a duration of about 1 hour. Now, you have an advantage. If you're in class 11 and if you're taking a class 11 1-year subscription, you can get the class 12 subscription absolutely free. So combined with this offer right now we are having, you just have to pay 15,870 rupees and you're getting the course for 2 years. In which case the price per course goes down below 15 rupees. Alright, per class you're paying only about less than 15 rupees. Okay. Other than this, there will be analysis session, there are practice tests available. All of those will also be there. Okay, your live test series along with practice session and other benefits are also included. Now, just like for class 12, for class 11 also we have a batch. This name is Achievers. Again, it's an all subject batch that's starting on August 4th. And for physics, we meet every 5:15 to 6:15, Monday, Wednesday and Friday. Alright, so with this note, let's begin today's class. Okay, so we know in the SI system of units, right, they are basically, let's start with this, right, very simple. Now see, there in the SI system of units, right, there are basically 7 units, right? We have the unit for length, right, and these are the physical quantity under SI units. Under SI units, these are the SI system of units. For physical quantity, what are the units, right? Length, again, the unit is meter, right? Then we have mass. For SI units, it's actually kilograms, right? Then we have time, which is given by seconds. Now then we have temperature, which is given by Kelvin, and also we have luminous intensity, right? Right, which is given by unit as candela, right, or CD, and we have amount of substance, which is again called as the unit is mole in this case, and we have current. Current, the unit is given in terms of amperes, right? For all of these 7 units, we have a dimension associated for the same. Okay, so here the dimension of any physical quantity, you write it within a square bracket. Okay, so the dimension of length is capital L within square bracket, dimension of mass is M, dimension of time is T, dimension of electric current is A, and the dimension of thermodynamic temperature is Kelvin, and the dimension of luminous intensity is candela, CD within bracket, right? And the dimension of amount of substance is mole. Now, what do you mean by a dimension, right? This brings us to a basic question. What do you mean by dimension? All right. Now, let's take density. All right. Density is nothing but it's a derived unit, right? So, it's given by mass by volume, right? Mass is a fundamental physical quantity, right? It's a fundamental quantity, right? But because density is a derived quantity, but volume again is a derived quantity. Write volume in terms of your fundamental quantity, right? That is length, breadth and height. Now, length, breadth and height all talks about the unit of, all talks about the fundamental quantity length, right? Some measurement of length, right? So, let's write the dimension for each, right? So, dimension of density for mass will be M, right, within square bracket. For length is L. Breadth again talks about measurement of length, right? So, again L. Height is again L. So, this is L to the power 3. You bring it on top. This will become L to the power minus 3. Now, you can represent this over here as M power 1, T to the power L to the power minus 3, T to the power 0. So, what it means over here is that when you're talking about the fundamental quantity density, derived quantity density, it has a dimension of mass, right? It has a dimension of mass, right? A dimension, dimension of density, right? Okay, sorry, in this case, the dimension of density in this case, just give me a second, right? The dimension of density if you take, right, which is nothing but 1, it has a dimension of 1 for mass, right? Dimension of density, it is 1 in mass, right? And minus 3 in length and 0 in time. So, these power terms that you see, which is raised to this particular dimension, what is the power term that you're seeing? Those are basically the dimension of a physical quantities. So the dimension of a physical quantity are the powers or exponents. These powers or exponents, okay, these particular terms, powers or exponents to which a fundamental quantity must be raised to represent that quantity completely. So whenever you want to represent a physical quantities in terms of their dimension, first part what you have to do is write that fundamental quantity in terms of their, or express them in terms of their fundamental quantity. See, this is a derived physical quantity, right? Express them in terms of their fundamental quantity, right? After that, substitute the dimension for the same, and the power terms that you're getting in each of these cases, these are called as the dimension of that particular quantity. So dimension of density, it is 1 in mass, -3 in length, and 0 in time. Okay, so this is all about your dimension. Now let's see one more example, right? What is the dimension formula for force? So very simple. If you know the answer, you can give it in the chat box. Okay, here if you take force is a derived physical quantity, right? Write this derived physical quantity in terms of fundamental quantities, right? So force can be written as mass into acceleration. Now acceleration is again a fundamental quantity. So write it in terms of the derived quantity. You've read saying that is actually right. Again, this mass is acceleration is velocity by time. Velocity is again a derived quantity. If you want to write it in fundamental quantities, it will be distance, right? That talks about the length by time into time by t. This is what you will get. So if you're taking the fundamental quantity, what is the dimension of force? It has mass to the power 1, right? And distance to the power 1. T goes to the top, right? So this dimension becomes t to the power -2. So so here m to the power 1, l to the power 1, t to the power -2, right? You've read saying you got the right answer. That is option C. That is actually correct. So this becomes your dimensional formula of force. All right. So first point, whenever you want to do a dimensional analysis, first point you're going to do is express them in terms of their fundamental quantities, and then write their substitute for the dimension. All right. Now, what is a dimensional formula? Okay. Now very simple. Right now we saw, okay, what is the dimensional formula of force? M L T to the power -2, right? Let's see, what is the dimensional formula of velocity? Can you guys tell me what is the dimensional formula of velocity? Velocity is distance by time. So the dimensional formula of velocity will be, distance will be L, time will be t to the power -2. Okay, t to the power -1. This is for velocity, right? So if you take for acceleration, right, you have velocity by time, right? Euphrates saying that is actually right. That's the right answer for velocity. Now for acceleration, again this will be, what is velocity? This is m t to the power -1 by t, right? This is by t to the power -1, right? So Euphrates saying whatever your answer you're giving, right, that is the dimension of velocity. Right now for acceleration, if you're taking, now this becomes L t to the power -2. Okay, so if you see all of these quantity that you have expressed over here, right, all of these quantities that you have expressed over here, this becomes your dimensional formula. Okay, the expression which shows how and which of the following quantities represent the dimension of a physical quantity, that is called as your dimensional formula of the given particular quantity. So all of these expression that you're seeing is a dimensional formula. Okay, next comes your dimensional equation. Very simple, right? If you have your dimensional formula, right, think about it. An equation has two sides, right? A right hand side and a left hand side. If you are able to express the dimensional formula in terms of equation, then it is called as your dimensional equation, right? The equation obtained by equating a physical quantity with its dimensional formula, that is called as your dimensional equation. See, for force, this is your dimensional formula. Now write this force within the square bracket. This is the right notation for writing. Within the square right bracket, write force. This is equal to what is the dimensional formula for force. Now this particular expression gives you dimensional formula. Okay. So for example, if you have acceleration, velocity is nothing but L t to the power minus 1. Now this gives you your dimensional equation. That's it. Okay. Now there is one more particular value. Alright. Now there's one more particular value that you can actually write right? Let's see. For the same, let's take a plane angle. Right? We know what a plane angle, right? It's one of the supplementary unit that you have taken. For example, let's say this particular arc length, right? Let's say this particular arc has a length L. Alright? And let's say this is the radius of the circle. So here also it will be R. Right? Then this angle over here is theta. Right? Your plane angle. So your plane angle, this angle is given by what? Length, right? Length of this arc by radius. Right? So arc by radius, when you're taking, this has a dimension of L. This also has a dimension of L. Right? Then this will be equal to 1 over here. Yuvraj, I'm trying to understand what you're trying to tell me. Could you please rephrase what you're trying to say? Now this is actually, the angle becomes 1. Right? So how do we express this? How do we express this in terms of dimension? Very simple. So in this case, if you're taking angle, it has a dimension of m to the power 0, L to the power 0, t to the power 0. Why? This becomes 1, this also becomes 1, this is also 1. So dimension over here is 1. Okay. Now this particular quantity we call as angle, we call it as dimensionless quantity. Alright. Any doubts here? Okay, so this is your dimensionless quantity. Now similar to this, we have another dimension quantity too, that is actually your strain. Okay, strain talks about what is the change in dimension. Okay, let's take, you have a rubber ball. Okay, whatever the dimension is, now apply some strain to it. Okay, so there is a change in the dimension, right? The shape will no longer be spherical. So in this case, what is the change in dimension by original dimension? That is actually strain. Okay. Now, change in dimension is what? In this case, change in dimension is what? Its unit is given in terms of L, right? Dimensional change by original dimension. Both will have the same dimension. So here again, the dimension becomes 0. So over here, again, the dimension over here becomes 1. These two cancels each other, right? The units cancels each other. Right. So in this case, if you take the fundamental quantities, whatever you're taking on both cases cancels each other. Now this will again be equal to 1. So strain is also a dimensionless quantity. Alright. Now there are different types of variables and constant. Okay. So we can classify them into four types. It's very easy to understand, might look lengthy, but it's extremely an easy concept. Okay. First one is a dimension variable, which means a particular physical quantity which has a dimension and it is variable. Okay. For example, take force. Force has a dimension and force can change depending on objects or situations or where it is actually applied. Right. So it is this particular force value changes from system to system, as well as it has a particular value as well. Right. It has a dimension as well. Right. Similar to force is also area. Area of a square is different. Area of a rectangle is different. Right. Area of a sphere is different. But all of it has a particular dimensional formula to it. Right. Area has a dimensional formula and it has a variable value. Now, similar case, we have dimensionless variable. Very simple. This particular physical quantity which has no dimension but has a variable value. For example, in this case, as we saw, angle. Angle changes, right? Depending on what object or where you're using it, angle changes, but it has no dimension, right? Similarly, strain. Strain also changes from object to object situations, means from object to object, but again, right, from one system to another, if you see, the strain changes, but it has no dimension. The variable associated with it changes, but dimension doesn't change, right? So think of this way. What is the angle of a straight line? To angle of a right angle triangle, right? All of these has different values, but it has no dimension. Angle itself has no dimension. Next, from variable, let's come to constants, okay? Some physical quantities which are constant value. For example, like your gravitational constant D or your Planck's constant, okay? Like your gravitational constant over here, right? This comes in the force equation for law of, so basically if you take F is equal to, for force of attraction between two objects, gravitational force of attraction, we know it is given by G m1 m2 divided by r square. This G that you have over here is a constant value, but you can express this particular G in terms of F r square divided by m1 m2, which means G over here has a dimension. Okay, so the physical quantities which has a dimension, but they are fixed values, right? These are called as dimensional constants. Okay, next you have dimensionless constant. These are constant quantities which has no dimension. Okay, they have a fixed value, right? For example, pi. The value of pi is 22 by 7 or it is 3.14, right? This is a fixed value, right? It's a constant quantity and it has no dimension also. Okay, these are called as dimensionless constants. So these are the four types. These are the types of variables and constants. Now, what is the use of learning about this dimensional analysis, right? So first thing is, let's understand what is a dimensional analysis. If you're using dimension to study any physical phenomena, then we call that as dimensional analysis. The method of studying a physical phenomenon on the basis of dimension. This is called as dimensional analysis. Alright. Now, there are four applications for this dimensional analysis, four uses you can say. One is, it lets us convert a physical quantity from one system of unit to another. Alright. Then, you can use dimension to check the correctness of a given physical quantity. Alright, then to derive a relationship between different physical quantities. These are the 3 points, right? These are the 3 applications of dimensional analysis, and we will look at each of them, right, in detail. Now, let's take first application is we're going to convert it convert a physical quantity from one system of unit to another, right? Meaning, let's say, for example, you have a physical quantity. Let's say the length of some object, right? So the length of this object, let's say, is around 8 centimeters. 8 centimeters is nothing but 0.08 meters. Hello Abhishek, good noon, right? So you can express in two different systems, two different units, right? Abhishek, I'm fine, thank you. How are you, Abhishek? How was your day, right? So here you can express it as two different units. Similarly, let's take mass of a particular quantity, right? Let's say we have a mass which is around 1 kg, right? This 1 kg mass can be expressed as 1 kg is nothing but 1000 grams, right? So, one thing you can see is the magnitude of a physical quantity remains the same, whatever may be the system of unit. Okay, let's say this is SI system of unit, the mass unit is kilogram, but in CGS system, the unit of mass is grams. Right. So, here if you take whatever is the SI system to CGS system, the value remains the same. That is 1 kg is nothing but 1000 grams. Right. But here you can use dimensional analysis to actually convert one quantity from a physical quantity from one system of unit to another. Okay. For example, right, let's take this quantity mass to be Q. Okay, generalized form if you're writing this mass, you write it as Q. Right. And then for kilogram, right, for kilogram over here, if you see this particular kilogram, in this case 1, right, in this case this will be if you're taking, alright, in this case this will be N1, right, this will be U1. Why? Meaning for this SI system of unit, this particular unit is, we have taken a unit and it has a particular numerical quantity associated to it. Okay, this N1 U1 is equal to, right, N2 U2. U2 being the unit in CGS system and N2 being the numerical associated with the same. Okay. For example, right now, let's say we have a particular quantity. We know the answer, but let's say you have this particular quantity. Let's say the quantity we have is mass, and we have 2.7 kgs of mass, and we want it in terms of grams. We know the answer for it, right? And in this case, that is right, Abhishek. Those are the four system of yes, the system of units you've given. Right, those are the different types of system of units. That is actually right. So over here, this mass, right? We don't know. We know what the answer is, but let's say we don't know what this particular answer is. Okay. So this is N1 numerical associated with one of the units. This is actually U1. This is SI system. This is equal to N2 into U2. This is in CGS system, right? We want to find this N2. In that case, what we can do is this particular unit U1, you can express it in terms of mass, right? Express it in terms of mass, right? Then length, the unit dimension of length and time. Okay, you can take it as, we don't know what is the power term in this case. Take it as that way, right? And this particular second system of unit, again U2, you can express it in terms of dimensional, in terms of mass, right? Length and time. Okay, right? Now, substitute for this U1 and U2, this equation you substitute for U1 and U2. Let's do the same. Right, let's do the same over here. What we're going to do, we have a physical quantity. We know what is N1 and U1 is M1 to the power A, L1 to the power B, right? We don't know what that particular term is, right? We want to find that, right? And in this case, N2 into M1 to the power M2 to the power A, L2 to the power B, T2 to the power C, right? Now, in this case, keep N, we want to find N2. So keep N2 wherever it is and bring this term to this down below over here. Then we can express it in this form over here. Okay. Now, using this particular equation, we can actually find how to convert a system of unit from one system to another. Okay. Now, very simple question we will do, right? We are just going to do an extremely small question. Let's say we want to find, okay, we'll do a very simple one, right? We will convert 1 joule, okay, into ergs. Okay, 1 joule is the unit for energy, okay, unit of energy in terms of SI system. Okay, ergs is the unit of energy in terms of CGS system. Okay. First thing, just when you're learning the application, right? Now, what we want to know, how many joules is, when you convert 1 joule to ergs, that is from SI system to CGS system, what is the numerical quantity associated with it? Okay. Here, energy is Q. This is equal to, energy is equal to, right, this energy is equal to 1 joule, equal to how many ergs? Okay, so this is Q equal to N1 U1 equal to N2 U2. What we want to find? What is N2? This is your application. This is one of your major applications of dimensional analysis. All right. Now, let's see that. And in this case, if you're taking, Abhishek, that Q you're talking about is a different one, right? That talks about a total charge of a system. We're doing dimensional analysis now. This signifies a physical quantity. Q signifies a physical quantity, right? So here, what we are going to do is, we're going to write, we know this is 1 joule. First thing, when you're doing this dimensional analysis, especially you're doing the application means, first thing is express it in terms of, in terms of the dimension, right? How do we write the dimensional equation for energy? So energy, dimensional formula of energy is nothing but M, right? Dimensional formula for energy, very simple. It is actually given as, energy is given as amount of work done. Okay, what is the work done? That is basically energy. Okay, work done is very simple. Work done is nothing but force into distance. Okay, unit of force is nothing but ml t to the power minus 2. Right, distance again has a unit of L. Right, this part we know. Right, and Abhishek, that is actually right. Okay, and here energy will be equal to ml to the power 2, right, ml to the power 2 t to the power minus 2. Right, this becomes your dimensional formula for energy. Okay, so first step is find the dimensional formula. Right, now what we are going to do is, now we are going to find now we are going to see what is this value. Right, we saw this u1 can be expressed as, right, u1 can be expressed as m to the power a, l to the power b, t to the power c. Right, so from here we can say a has a value of 1, b has a value of 2 and c has a value of minus 2. Alright, now from here let's use the formula we saw in the last class, right, let's do this now. Let's use the formula we actually did in the right, let's use this particular formula, that is actually n2 is equal to n1, this formula right now, and substitute it in this particular equation to get the answer. Right, so here we know n2 is equal to n1 into m1 by m2 to the power a, t1 l1 by l2 to the power b, and t1 by t2 to the power c. Right, n1 we know the value. Right, n1 energy equal to 1 joule. Right, so this is n1, this is u1. So n1 is actually 1. m1, if you see, what is the unit in CGS system? Right, first unit you have taken is, SI system. Right, in first unit we are taking in this case is SI system. Right, mass in SI system is given as 1 kg. Right, and m2 is given as mass over here for the second system is given as 1. Right, because this is in terms of grams, that is mass in CGS system. All right, to the power a we found the way to be 1. Now length in terms of SI system, because why, we are converting 1 joule to how much urges, that is what we want to find. Right, this is SI system, this is CGS system. Now take this dimension of length for SI system. Now L has a unit of 100, we can say L is actually 1 meters. Right, the unit is 1 meter, but in CGS system we measure in terms of centimeters. Okay, and we found B to have a value of 2. Time, if you're taking, again in both units it's second, and we found t to be minus 2. Now we are going to rewrite. We want everything in terms of CGS system, right? So we have to write everything we've written in SI system to CGS system. Now 1 kg is nothing but 1000 grams. Right? Similarly, we also have 1 centimeter is nothing but 100. 1 meter is nothing but 100 centimeters. This is given in terms of seconds. Okay, now if you actually cancel these two, and Abhishek, I've told you in the previous class itself, Abhishek, after the class today we have an electrostatic class. After that the notes will be automatically generated in the system, right? After which you can actually take it from the community, or you can also take it from the, I don't share it because the new notes is downloadable, but don't worry, I will share it today after the class. All right, now centimeters you can cancel, grams you can actually cancel. All right, so from here you have 1 into, okay, this is 10 to the power of 3 the whole power 1, right? This is 10 to the power of 2 the whole power 2, right? This is nothing but 1 to the power of minus 2. 1 to the power of minus 2 will anyway give you 1 only. So this will be 1 into 10 to the power of 3 into 10 to the power of 4, right, into 1. So here N2 will be nothing but 10 to the power of 3 plus 4 is 7. So 1 joule is nothing but 10 to the power of 7 urges. So 1 joule in SI system is equal to 10 power 7 joules in CGS system. So this is the first application of your dimensional analysis. That is, you can convert a physical quantity from one system of unit to another system of unit. Okay, so again, if you have any doubts right now, please ask me, because we will be moving ahead with another question. Right? We will move with the second unit. We will move with the second application. So if you have any doubts, ask me now and there itself. All right. The second application is to check the correctness of a given physical quantity. Okay. Now here, this is basically based on the principle of homogeneity of dimension. What it means is the physical equation will be dimensionally correct if the dimension of all terms occurring on both sides of the equation are the same. Okay, then it is actually correct, right? For example, let's take this particular quantity, for example, let's take this particular quantity, right? Your equations of motion, right? That is the second equation of motion, no? To find the distance, displacement, right? Or the distance, S is equal to ut plus half at square. Now, using the principle of homogeneity of dimensions, we can check whether this given equation is dimensionally correct or not. Okay, so here if you take, right, we will do dimension of each terms over here, right? So dimension of distance, S, if you see, this is actually L. Dimension of distance gives you the measure length, so it gives you L. Okay, all right, Abhishek, that is actually nice. Okay, and the dimension of this particular quantity over here, U basically talks about the initial velocity. Velocity is given by L t to the power minus 1, right? Into the second quantity is time. Dimension is t to the power 1. So here these two cancels. Again, you end up getting the dimension of length again, right? Take the last quantity, that is half. What is the dimension of half? Acceleration into time square, right? Half anyway is a constant, right? Constant value, dimensional constant. So and with this, it actually in this case you don't have to give these particular value, right? So here acceleration will be L t to the power minus 2. That is your value for acceleration, and time over here is t to the power of 2, right? Then these two cancel, so what you have is basically L. So if you see, the physical equation will be dimensionally correct if the dimension of all terms on both sides of the equations are the same. Here the dimension of this particular quantity is L, dimension of this particular quantity is also L, and dimension of this term is also L. Then this equation that you have taken is actually physically correct. Alright. And if you want to do for V is equal to U plus AT, what do you think, Abhishek, would be the answer? So here velocity is given in terms of L t to the power minus 2. Right. Now U is actually given in terms of again, initial velocity U is also given in terms of L t to the power minus 2. Acceleration is given in terms of L t to the power minus, my mistake, L 2 to the power minus t to the power minus 1. Okay, minus 2, right? And here we again have another quantity t. Right, so the t over here gets cancelled, and what you get over here is again t to the power 1. Right, so whatever is the dimension, right, of both of this particular equation, all the terms has the same dimension, right? Then this equation is actually dimensionally correct. Okay, now this particular principle of homogeneity, right, is just based on the fact that the physical quantity of the same kind, for example, you can take velocity, that is a particular physical quantity, right? This particular physical quantity velocity can be added or subtracted with velocity, right? As well as if you take but you can take two physical quantities. For example, take force. You can add force with another quantity which is again force, right? You can add force, subtract force, right? So these quantities can be compared, but you cannot add velocity with force. That is something you should remember. You can add the same kind of physical quantities but not different ones. Okay, so this is your second application for dimensional analysis. All right. Now let's do one more question over here. Let's do one more question. Let's say we have gotten this question is again taken from your reference books, right? So let's say you have an equation which says half mv square is equal to mgh. How do we check whether this equation is dimensionally correct or not? Okay, you can also share it in the chat box whether it's dimensionally correct or not. Mass has a dimension of m, velocity has a dimension of L, t to the power t to the power minus t to the power minus 1, right? The whole square, right? Here mass over here is m, right? And gravity over here is acceleration due to gravity is t to the power minus 2 into height talks about length. So again L, right? So here we have m, this particular quantity, take it inside, this becomes L square t to the power of minus 2, right? And this will be equal to, on this side you have mass L into L, right? So L to the power 2 t to the power minus 2. So this equation, if you see, the dimension of your left hand side is equal to the dimension on the right hand side. So this equation is dimensionally correct. Okay, now let's check for one more quantity you might come across in your in this grade, right? That is basically your torque, right? Torque is given by force into distance, right? Now the dimension of torque, if you take, right, torque is given as the force into distance, right? So torque in this case, if you see, the dimension of torque, if you see, that is nothing but m L t to the power minus 2, right, into the distance L. So torque is basically given as m L to the power 2 t to the power minus 2. Okay, this gives you the dimension equation of torque. All right. Now here, if you see, if you substitute for force and also for distance, you will get back the same equation, right? So this is your, this becomes, you can use this particular relation to also check what is your, okay, this is your, let's say, I'm sorry. So this gives you your dimensional formula for torque. Let's see the angular, what is the dimension formula for angular acceleration? Okay, alpha is angular acceleration. So dimension for angular acceleration is what is angle by time square. That is your, this is for angular acceleration. Right, angular acceleration means in this case we are looking for a rotational motion, right? That will be angle by time, right? Angle over here, what has a dimension? It is a dimensionless quantity, so it has a dimension of 1, right? And time, if we take the dimension, it will be t to the power 2, right? So angular dimension has a unit of t power minus 2, right? Now what we want to do is, and now let's take moment of inertia. Moment of inertia has a unit I, right? Sorry, is given by I. This is nothing but mass into distance square. All right. So this moment of inertia in this case has a dimension of what? Has a dimension of mass into distance square will be L to the power square, right? Now what we want to prove is, what we want to prove in this case is that the torque is equal to angular acceleration times moment of inertia. Okay, what is that? Just think of the dimensional formula for angular torque over here. This is m L to the power 2 t to the power minus 2. Now angular here I over here, moment of inertia has a dimension of m L to the power 2, right? Angular acceleration alpha has a unit of t to the power minus 2. So dimension of right hand side is equal to dimension of left hand side. So this equation, torque is equal to angular acceleration into moment of inertia. This is angular acceleration into moment of inertia is dimensionally correct. Alright, this is your second application. Now coming to your third application, okay, this is, it helps us to derive relationship among different physical quantities. Okay, so again, by making use of the homogeneity of dimension, we can derive expression for a physical quantity if we know the various factors that it depends on. That's it. Okay, very interesting question. Let's try to find, okay, let's try to find the centripetal force equation. Okay, now first of all, if you want, using dimensional analysis, using dimension, if you want to find what is the equation for centripetal force means, first you should know what are these quantities, right? First you should know what are the physical quantities, the various factors on which it depends on, right? We should know what are the various factors this force depends on, okay? So here what we can say, centripetal force means very simple, right? Think of an object, a car going in a circular motion, right? And or think, just tie a stone or something to a thread and actually rotate it. All of this has a centripetal motion. All of this is actually a centripetal force, right? Now, if you take the centripetal force over here, there are a few quantities that this particular force depend on. One is, what is the mass, right? The applied force is proportional. These are the quantities, various factors this force equation will depend on. That is mass. Hello, Ram, right? That is mass over here, right? Then we want to know, we don't know to what power, dimensionally we don't know what power of mass it is, right? Is it m, is it m square, is it m cube? We don't know that, but we know it depends on this particular mass. So mass to the power a, or whether is it even dependent on mass, okay? That also we are going to check, okay? First it depends on mass, okay? So to derive the expression for centripetal force acting on a particle of mass m, now this particular force is moving with the velocity v, right? So this moves with the velocity v, and also if you take, it is at a distance, if you take from the center point O, if you look at the distance, it has a distance r. To what power it is, we don't know. So these are the three quantities this object actually depends on. The mass, what is the velocity in which it is traveling, as well as the radius of the circle, right? Now, here, to remove this proportionality constant, let's bring in a constant k, okay? And this particular k is a dimensionless constant, which means it does not have a, right, it is a dimension, this particular k over here is a dimensionless constant, okay? Dimensionless constant means they do not have any dimension, but they have a constant value, okay? That could be anything, right? Now, in this case, if you see, first thing what we are going to write is, first point you need to write is express force in terms of its dimensional equation. That is, force is nothing but, this is m to the power 1 t l to the power, right, force is given in terms of l to the power 1 t to the power minus 2, right? This is the force equation. Right, let's actually do this. Let me do this in a separate page over here. Okay, so we know in this case force, right, is actually proportional or equal to the constant k, right? It's a dimensionless constant, m to the power of a, and velocity to the power b, and radius to the power c. Force has a dimension of m, l to the power t to the power minus 2, right? That becomes your force equation. Now this is equal to, the dimension value of k is basically 1, because why? It is a dimensionless constant, okay? So here the value is going to be 1 into, because for a dimensionless constant, if you're taking in this case, it is basically 1, okay? And m to the power a, right? M to the power a is nothing but a mass to the power a. Velocity can be taken as L t to the power minus 1 to the power b, and c, radius is again talking about the length, right? L to the power c. Right, so let's rearrange this whole form and write. We have m to the power a, right? Here we have m l t to the power minus 2. Here we have m to the power a, l to the power b, t to the power minus b, l to the power c. Right, this term we can write it as l to the power b plus c. All right, now we have m to the power 1, t to the power 1. Now we can equate the power terms on both sides. For m, we can equate a is equal to 1. So first we got the value of a, right? Now for L, before we go with L, let's go with t. Okay, from t we know this particular value, right, of t, if you take, that is minus b is equal to minus 2, which means b is equal to 2. We got the value of b. Finally, if we take the term for the length term, power terms of length, right, what we have is L to the power 1 is equal to L to the power b plus c, right? This base quantities are same, so power terms can be equated. So b plus c is equal to 1. We know what is the value of b. B is actually 2, right? 2 plus c is equal to 1, c is equal to 1 minus 2, so c is equal to minus 1. So we got three quantities over now, which we can substitute on this equation over here, right? Here f will be equal to k m to the power of 1, right? M to the power of 1. Bhavani, I'm fine, Bhavani, thank you. How are you? And v to the power of 2, r to the power of minus 1, right? So you can again write this value as m v to the power of 2 by bring this down. So this will become r to the power of 1. That's it. You got your equation for centripetal force. F is equal to mv square divided by r. Right? This becomes your equation for centripetal force. But here we have certain limitations. Okay. In this case, using this particular dimensional analysis, we cannot find the information about these dimensionless constant, right? In this case, this is k dimensionless constant, right? We cannot find any information about this. If you want to know that value, you have to do it experimentally. You can't find it using dimensional value, okay? Why in all cases, if you take, we always took only three variables, right? See, force when we took also mass, length, and in this case, this equation that we derived only depended on three variables. Previous equations that we did where we tried to convert the system from one system to other, we took only three variables, right? Because any physical quantity which depends more than three variables means you cannot apply dimensional analysis. It fails, okay? It works only up to three physical quantities, okay? Only when an equation or any physical quantity it has three variables, only then you can take, okay? Or three physical quantities, okay? More than that, it doesn't fail, okay? Now, remember we did the equation of S is equal to ut plus at square earlier, right? Here we did this equation of S is equal to ut plus half at square. Okay, now here also this particular formula, right, we got this L is equal to, both sides we got L, but each term had this dimension of L, right? So it fails when a physical quantity is the sum or a difference of two or more quantities. Even then the limitation actually fails, okay? These are some of the limitations of your dimensional analysis. Next is, if at all you have a term which involves trigonometry or logarithmics or exponents, you cannot use dimensional analysis. All right. Okay, if you're sometimes this method becomes extremely complicated, okay? When you have a dimensional constant like your gravitational constant or Planck's constant, when you have such kind of constant involved in your equation, this method becomes extremely complicated. So these are your limitations of your dimensional analysis, right? So right now what we are going to do is we are going to do one more question before we end today's class. So if you have any doubts, start asking me right now itself. Any doubts you have till whatever we did dimensional analysis in one shot. I will do one more question. Before that, if you have any doubts, please ask me right now itself, right? Let's see. Let's take a simple pendulum, right? So you have a thread or the length of this, you have a bob attached to a string, right? And this particular bob oscillates around its mean position, right? This is what we know. Now for a simple pendulum. So in this case, the time period of the simple pendulum depends on three different variables. One is, what is the mass of this particular bob over here? What is the length of the string over here? And one more quantity of why it is about going about its mean position is because of gravity, right? It's under acceleration due to gravity, right? So that is because that in this case is g to the power of c. Right, that's why it oscillates. It goes down to this one position over here. It comes back down again. That is because of acceleration due to gravity, right? These are the three quantities time period depend on. Now, knowing this, let's find the equation for time period using dimensional analysis. Okay. So here, to remove the proportionality constant, we use the dimension k. Right. Now, what is the dimension of time period over here? Time period means over here, obviously, mass will be 0. Length is also 0. Time is actually 1 because we are talking about the dimension of times, right? So that is actually 1, right? So here the fundamental quantity is just time, so t to the power 1, right? And we know this dimensionless constant k will be taken as 1, and m to the power in this case, or you can just take that, and mass is given in terms of m. So you have m to the power a, and length is given as L to the power 1, right, L to the power b, and acceleration due to gravity is given as L t to the power minus 2. Right, so you can write this as m. Here mass is quantity, physical quantity of mass, and length is 0, time is 1. Here you have m to the power of a, L to the power of b, L to the power of c, and t to the power of minus 2c. Right, so here you can write these two quantities as together and you'll get L is equal to b plus c. Right, that's it. Now you can power like terms on the base, you can equate the power. A will be equal to 0. So mass quantity disappears. Right, time period of the pendulum does not depend on mass because m to the power a becomes 0, this becomes 1. Alright, next quantity we are going to consider is, there are two quantities. First, what we will do the one which has just one terms, right? That is c over here, right? 1 over here is equal to minus 2c. So c is nothing but minus 1 by 2. Okay, now let's come to the next term. That is, in this case we have b plus c is equal to 0. Right? Now what is c over here? Minus 1 by 2 is equal to 0. So b is nothing but 1 by 2. Okay, let's substitute the same in this equation over here. So you have k m to the power 0, L to the power 1 by 2, g to the power minus 1 by 2. Okay, now the time period becomes k m to the power 0 is 1, then you have L to the power 1 by 2, g to the power 1 by 2, I am taking it down. Alright, now this is nothing but k into 1 by 2 is nothing but root, right? Root L by root g. Root L by root g I can express as k into root of L by g. K is equal to 2 pi root of L by g. Okay. Alright guys, with this note we are coming towards the end of today's class. Alright guys, so once again, before we end the class, one more question. What are the applications of dimensional analysis? That is to convert a physical quantity from one system of unit to another, to check the correctness of a physical quantity, to derive a relationship between different physical quantities, all of the above. Okay, so the answer over here is going to be all of the above. All of this above are actually dimensions of this particular physical quantity, right? So with this note, we are towards the end of the class. Once again, we are back with the 41% off. That is, if you're taking a 6 months course, you get an extension of 1 month, right? And you pay only 9,200 rupees and you will be saving 3,678 rupees. Okay. Similarly, if you take 1 year, you get 3 months extension and you only have to pay 15,870 rupees and you're saving 34%. Now, if you take a two years course, you can get up to 6 months extension. So you're getting the course for 2.5 months and you only have to pay 26,450 rupees and you're saving 41%. Now this particular offer is extended till 31st July. To avail this particular offer, you can actually use my code MTIS10. If you want to know more details, you can call this number over here, right? At the same time, always in this case, if you see whatever amount you're paying, it's for 4 subjects: physics, chemistry, math and biology, right? So if you're in class 12 or 11, you have an advantage. If you take a class 11 subscription, class 12 subscription is absolutely free for you guys. We have an upcoming batch that's starting on August 4th. The mode of delivery is going to be in English. So for physics, we're going to meet every 5:15 to 6:15, Tuesday, Thursday and Saturday. Other subjects with the timing is also given. Similar for your class 12, class 11, class 12 also, we have an achievers batch starting on August 4th. And over here again between 4:15 to 5:15, 6:15 p.m. 5:15 to 6:15 p.m. every Monday, Wednesday and Friday we will be meeting, alright, for physics. Other subject and the timing is also given. You can follow me on my community and you will never miss any updates from any of your educators. So go down to the description box, my community link will be given. Go to the community and there will be some MCQ type question asked from the first 2 units. Please try to try answering them. In any of the videos, if you find any inappropriate content and if you report the same, you can claim a prize. And if you like the class videos, right, please share it among the friends and subscribe to the channel and click on the bell icon to get further notification. Alright, then I'll see you all in the next class. Today again we have a class around at 4 p.m. for vectors, and I'll see you all then. Take care.